In this video, consider one numerical on DFT. A length 12 sequence is given by x of n with 12-point DFT given by x of k. Evaluate the following functions of x of k without computing DFT. So in this numerical, x of n sequence is given, that is x of n is equal to 3, minus 1, 2, 4, minus 3, minus 2, 0, 1, minus 4, 6, 2 and 5. So here this is for x of 0, x of 1 and so on. So this is last sample, that is x of 11, and this is x of 0. In between these are 1 to 10. So here given 12-point DFT, it means that n is equal to 12. Now with the help of this, we are supposed to evaluate x of k without computing DFT. Let's consider the first case. We know that DFT of any sequence x of n is nothing but x of k, which is given by summation n equal to 0 to n minus 1 x of n e power minus j 2 pi by n into k for k less than or equal to n minus 1 greater than or equal to 0. This is the basic definition of DFT. Now consider the first function, that is x of 0. So here we can observe that we'll call it as equation 1. Now look at equation 1. We'll get x of 0 only when k is equal to 0. Now let's substitute k equal to 0 in equation 1 so that we'll get x of 0. Substitute k equal to 0 in equation 1. Therefore I can write x of 0 is equal to summation n equal to 0 to, here n is 12, 12 minus 1 is 11, x of n e power minus j 2 pi by n into 0, as k is equal to 0. Therefore I can write it as summation n equal to 0 to 11 x of n. That is, expanding this summation, I can write n equal to 0 to 11, that is x of 0 plus x of 1 plus so on till x of 11. It means that we are supposed to consider all the samples of x of n. Just by adding all the samples of x of n, we will get x of 0. Therefore x of 0 is equal to 3. We'll add all these samples, minus 1 plus 2 plus 4 minus 3 minus 2 plus 0 plus 1 minus 4 plus 6 plus 2 plus 5. So simplifying this, we will get 13. Therefore x of 0 is equal to 13. That is, now substitute k equal to 6 in equation 1. Therefore I can get x of 6 is equal to summation n equal to 0 to 11 x of n e power minus j 2 pi by 12 into n into k is 6. Or I can represent the same thing as summation n equal to 0 to 11 x of n e power minus j. Here we have 6 divided by 12, that is, I can write 2 pi by 2 into n, or I can write it as summation n equal to 0 to 11 x of n. Here 2 will get cancelled, will get e power minus j pi n. Therefore I can write it as here e power minus j pi n is nothing but cos pi n minus j sin pi n, which is nothing but cos pi into n, as this value will be 0. We can see that if we take n equal to 0, then cos 0 is 1. If we take n equal to 2, then cos 2 pi is also 1. If you take n equal to 4, cos 4 pi is also 1. It means that for all even values of n, the value of this cos pi n is plus 1. If we take odd numbers, that is if n is equal to 1, it will be minus 1. If we take n equal to 3, it will be minus 1. So for all odd values of n, this function will be minus 1. So I can represent it as cos pi 1 as minus 1 power n. So for all even values of n, it will be 1. For odd number of n, it will be minus 1. Therefore now I can represent it as x of 6 is equal to, we have summation n equal to 0 to 11 x of n. Here this term is replaced by minus 1 power n, which is, so now here we can see that, as I said, for even values of n it will be 1, and for odd values of n it will be minus 1. So here the last number is 11, so definitely the number will be minus. Therefore I can write it is minus 1 into x of n, that is summation n equal to 0 to 11 x of n is already we have calculated, that is 13. So it will be 13 is equal to minus 13. Therefore x of 6 will be equal to minus 13. Consider the third case, which is summation k equal to 0 to 11 x of k. Summation k equal to 0 to 11 x of k. Now we'll consider IDFT expression, that is, we know that IDFT of x of k is given by x of n is equal to 1 over n summation k equal to 0 to n minus 1 x of k e power j 2 pi by n into k. N is equal to 12, so I can write it as x of n is equal to 1 over 12 summation k equal to 0 to 11 x of k e power j 2 pi by 12 into n into k. Now here we can observe that we need to calculate summation k equal to 0 to 11, this function. So here we can find summation k equal to 0 to 11 x of k. Now to extract this function, the value of this e power j 2 pi by 12 n into k must be 1. So this value will be 1 only when n is equal to 0. Therefore, if n is equal to 0, then e power j 2 pi by 12 into n into k is equal to 1, because n equal to 0. So therefore now we'll take n equal to 0, x of 0 is equal to 1 over 12 summation k equal to 0 to 11 x of k. So therefore I need this function, that is summation k equal to 0 to 11 x of k is equal to, multiplying this 12, taking this 1 over 12 on other side, will get 12 into x of 0, which is nothing but 12 into, so x of 0 value is 3, this is x of 0, that is 3, which is equal to 36 into k into x of k. Now here I will consider this e power minus j 4 pi by 6 into k x of k. This one I will also write it as the same function in terms of standard twiddle factor, that is e power minus j 2 pi by n is 12 here, into 4k. So which is same as this one, x of k. So we know that circular time shift property, I can write x of n minus 4, the DFT of this is given by e power minus j 2 pi by 12 into 4k x of k. That is same thing. It means that the IDFT of this function is nothing but x of n minus 4 of n. Therefore now I can write, we know that IDFT of any sequence x of k is given by x of n is equal to 1 over n summation k equal to 0 to n minus 1 x of k e power j 2 pi by n into k. Now therefore the IDFT of this function is given by x of n minus 4. So here n is nothing but 12 is equal to 1 over 12 summation k equal to 0. So therefore I can write IDFT of this function, that is e power minus j 4 pi by 6 into k x of k will be multiplied by this term, that is e power j 2 pi by n is 12 into n into k. So now in this expression we need to find this value. So to keep this value we need to make this term equal to 1. So this term, entire term will become 1 when n is equal to 0. Therefore now I can take n equal to 0 here, that is x of minus 4 12, which is nothing but x of 12 minus 4, that is nothing but x of 8 is equal to 1 over 12. We have here summation k equal to 0 to 11 e power minus j. We have 4 pi by 6 into k x of k. So therefore I can write summation k equal to 0 to 11 e power minus j 4 pi by 6 into k x of k will be equal to, this 12 will be multiplied with x of 8, that is 12 into x of 8, which is equal to 12 into, so value of x of 8 is, so this is 0 1 2 3 4 5 6 7 8, that is minus 4, which is minus 4 is equal to minus 48. Now consider the fifth function, that is summation k equal to 0 to 11 x of k square. So we know that from Parseval's theorem we can write that summation by Parseval's theorem n equal to 0 to n minus 1 magnitude x of n square is equal to 1 over n summation k equal to 0 to n minus 1 x of k square. So therefore I can write summation, we need this one, k equal to 0 to n value is 12, that is n is equal to 12, so it is 11 magnitude x of k square is equal to, this n I will take on left hand side, that is n into summation n equal to 0 to 11 x of n square. So therefore, simplifying this, I'll keep this term as it is because we need the same function. K equal to 0 to 11, x of k square is equal to n value is 12. So here now the x of n is the given sequence. So we supposed to take the square of each samples. Therefore, we can get here. Let me write the x of n sequence. We'll expand the summation. That is for n equal to 0, x of 0 square. So x of 0 is 3. 3 square is 9. Similarly, we'll take the square of each sample. That is 9 plus 1 plus 4 plus 16 plus 9 plus 4 plus 0 plus 1 plus 16 plus 36 plus 4 plus 25. So simplifying this, we will get 1500. Thus, we have computed all the functions without computing DFT. Thank you for watching.